Hi and good afternoon, everybody. Welcome to today's joint webinar hosted by MasterSeries and IDEA StatiCa. My name is András Hörbély and I'm a sales manager at MasterSeries. Today, I'm joined by Ralph Pullinger, product manager at IDEA StatiCa, and Patrick McGinley, technical advisor at MasterSeries. We are here to present an exciting new feature, the link between MasterSeries and IDEA StatiCa. During the session, we will walk you through the new function, demonstrate the capabilities through a customer project, and of course, answer any questions you may have. Let's move on to the main topic of today, the new link between MasterSeries and IDEA StatiCa. We are excited to announce that MasterSeries now links seamlessly with IDEA StatiCa, allowing for complex and non-standard steel connection design. This integration saves valuable time by exporting frames with their results, eliminating the need for double modeling and handling, and significantly reducing the risk of manual errors. Of course, our trusted and integrated master key connection design module remains the most efficient and code compliant solution for standard everyday steel connection design by ensuring compliance with Eurocode and gridbook standards. However, these standards and publications are limited and do not have calculation methods for every kind of connection. And as we experience daily, even simpler structures may require connection configurations that fall outside these standards, but we still need to find a solution. To fill this gap, we have partnered with IDEA StatiCa, which specializes in the analysis and design of non-standard and complex steel connections. This slide is about the design workflow. Ralph, please explain how the integration works and the benefits it brings to the design process.
Thanks, András. Yes, so what we are able to do with IDEA StatiCa is to take either BIM information or information from a global analysis model or FEA, in this case, MasterSeries, and we can pull that into a solution we call Checkbot. This will, think of this as the hub for your information. It is a repository for connections that are imported directly from MasterSeries and or members. With the connection application, we are able to fully design, analyze and design to multiple codes and output into various formats, including IFC and 3D WG, but also present the necessary reports that you require for your design checks. The result of this is we have no data loss, which is important. The results integrity is maintained. So essentially, as András has already pointed out, the risk reduction is significant, and this makes for a really efficient design and code check workflow. And of course, you've got access to all the reports and the multiple 3D formats. And today, we will be focusing on the link from MasterSeries through Checkbot into connection and then out into our project printouts.
Okay, thanks. To illustrate the integration in practice, we are going to look at a customer project. The structural design of this project was carried out by Subteno, our customer. The project involved repurposing an old agricultural barn with a slender central dual-pitch porter frame with lean-to rafters and columns on each side into a production facility. The goal was to transform the space into clear span while retaining the existing structure, as the client preferred not to take down the building and rebuild. One of the key challenges was the removal of all internal columns and ensure the stability of the structure during and after the removal of internal supports. The solution was to convert the existing porter frame into a lattice roof. This allowed the new steel to be installed before column removal, providing temporary stability. They designed bolted connections to accommodate the added steel elements. Moreover, the transformation helped to reduce the embodied carbon of the project, as the designers repurposed the existing structure and completed the modifications without removing the cladding and purlins. Next, we will demonstrate the integration live, showcasing how the link works using this customer project as an example. Okay, here we are. So let's jump straight into the master series. So as I already mentioned, this project was about repurposing an old agriculture barn into a workshop facility. The designers used MasterFrame to carry out the analysis of both the existing and proposed structures, and this is the 3D structural model in MasterFrame. We filter for the original structure. Yes, I'm gonna go to grid line 5. Yes, it's more simple. So we can see that there are very slender central dual pitch portals with lean-to rafters and columns each side. Yes, the original columns do not exist in the model. However, I can just quickly draw these columns back. So here we have the original columns. Sorry, it doesn't look good, but yeah, you can understand. So yes, here we can see only the remaining section of the columns, as the designers used these as vertical members in the new lattice roof. If we take a look at the sections, that we can see that the existing members are mainly S275 UB hot rolled cross sections, and if we switch back to the final solution, then we can see that the added structural elements with which they converted the structure into this lattice roof. So these are the new structural elements, the diagonal angles, and the hot rolled UC core members. The new structural elements are S355. On the side, first they installed the new steel members with welded connections, then cut and remove the columns. The designers also added some additional extensions as well. Okay, let's have a quick overview of the model. So as we can see that the designers modeled the diaphragm actions of the roof's cladding with semi-rigid stiff decks. The semi-rigid stiff deck is based on an underlying finite element surface, which models the cladding based on its thickness and Young modulus. Let's quickly review the loadings. So we have full area loads, area dead and live load were applied to the model using floor and roof area loading panels. The area loading panel is an extremely useful tool in applying gravity, dead and live loads across the floor and roof areas of a model. It enables you to apply loading to floor panels and have the loads automatically distributed onto the members around the perimeter of the panel, depending on which directions you have chosen to span the panel. The applied panels are one-way spanning panels, and the spanning directions follow the direction of the purlins. And we have 0.2 kilonewton per square meter and 0.1 kilonewton per square meter dead load and 0.6 kilonewton per square meter live load on the roofs. The wind loads in all four main directions were also generated and applied using the MasterSeries inbuilt wind analysis module. The wind cases, of course, not only contain the global wind, but combine the wind loads with internal pressure and sanctions. We can see the coefficient values, the wind pressures, of course, and the zonings applied to the panels. The wind module defined the wind speed and the pressure values based on the site location. So here we have a nice Google-based UK site. Okay, let's move on. Yes, the wind load, similar to the air loading, the wind loads are applied to one-way spanning panels. With wind panels, the spanning directions follow the direction of the purlins and then the side rails. Just a quick look at the load combinations. So if we go into our load cases, you can see the different load cases. We have that plus live plus wind, in which the live is the leading, and we have that plus wind, that is favorable. Okay, the load cases have been generated according to the Eurocode using the auto generate function. And if we go into our load combination tab, then we will see here all the different load cases with the load factors that the program uses. Okay, let's move on to the design phase. Just a quick overview of the steel design. All the structural elements were designed to the Eurocode. For the beams and the columns, the engineers used the general axial with moment checks, which includes both local capacity and buckling checks. For beams, they applied the purlins as lateral restraints, positioned every 1.5 meters on the members. For the columns, they only use the incoming members as lateral restraints. To the bracing element, the strut tie check was applied. Okay, let's move on to the still connection design. Okay, our customer designed most of the standard connections with our master key connection design module in integrated mode within the master frame. This integration helped them to speed up the design process, as they only needed to select the node and place the connection type they wanted to use, and then the program automatically created the connection model based on the frame and imported the frame results from all the load cases. In integrated mode, you can also create connection design groups to group together those nodes where you want to use the same connection layout. The forces and moments from all the load cases from all the members within the group will be examined together, and the optimum solution, so all the criteria will be produced. Okay, let's just quickly review the design connections. So the designers check the existing apex connection here, which is a beam-to-beam moment connection. There are two bolt rows, and the end plate is extended at the bottom and strengthened with this Gaza stiffener. The designers also check the rafters existing beam-to-column connection. It is a very simple standard connections, and most of the column bases were also designed and checked inside the master series. The connections are all moment resisting base plate connections. Some of them have extended end plate with both rows positioned outside the cross sections. Others are simple symmetric base plate connections. However, there are some non-standard steel connections that fell outside of the scope of the Eurocode and the Green Book. So these connections couldn't be designed inside the master series. For example, this newly formed bottom cord connection. This is a good example where the designers use the upper part of the existing column as the remaining vertical member and bolted the new bottom cord members and diagonal angles to its flanges. Moreover, there are also connecting perpendicular tie members in this connection. The designers used IDEA StatiCa to carry out the design of this complex non-standard connection. However, there wasn't yet a link back then between the master series and IDEA StatiCa, so they had to create the IDEA StatiCa model from scratch and manually add the forces. The good news is that we just released a new link between master series and IDEA StatiCa that eliminates the need for double modeling and manual work. So under the beam exchange main menu, now we can find a new IDEA StatiCa function. I have to note that the beam exchange menu is only available for users with the MasterCAD BIM module on the license. However, if you want to test the link, we would be happy to add it temporarily to the license. On the upper screen, there are 4 tabs for the settings. On the link tab, we can select the program directory of IDEA StatiCa and the project directory, which will be created during the export. The program pre-selects the program directory of the latest IDEA StatiCa version. However, we have the option to change it if for some reason we want to use a previous version of it. And the project directory by default is the same as the master frame file. However, you have also the option to change it. On the load case tab, we can select the load cases we want to export. We can select a single load case, or using the shift button or the control button, we can select multiple cases. However, I have to mention that the number of the selected results can significantly increase the import time, especially for a bigger structure. So it is worth selecting only the dominant load cases. And there is an option to auto-select the critical ones. On the member tab, there is an option to select which member type we want to use for the export. We can choose to export the model with their physical members, which keep the members as one unit without internal nodes, or we can choose to use the analytical member option. In this case, the program automatically splits up the members and creates internal nodes at each connecting member. By default, it is worth using the analytical option, as the IDEA StatiCa needs a member end for all the connecting members in a joint. And on the last tab, the export tab, we can select the resolution of the results. So we have 2 options. Using the connections options, we can choose to export only the member end forces which is satisfactory if we export the model for connection design only. However, if we want to use the member design tool in IDEA StatiCa, we must export intermediate forces for the members as well. In this case, if we switch to members, then this slide bar is activated, and with this slide bar, we can control how many internal points we want along the selected members. Now I'm selecting the connections as we will do connection design. Once all set, we can either start the export by selecting the members we want to export and then click on Start Checkbot, or we can start the checkbot first and then select the member to export. Now I'm going to select the whole model first. And now I'm going to click on the checkbot. It is not necessary to export the whole model, so you can export only a part of it as well. Loading. Okay, once IDEA StatiCa checkbot is loaded, you can create a new project, and by clicking either connections or members, it depends on the purpose of the import. Under the import menu, we can initiate the model export. Now we will do connection design, so I'm click on connections. The good news is that the link remains live in the background, so you can either close the checkbot or go back to MasterSeries. So we can go back and we can add additional elements. We can add additional elements to the selection, or we can update export results if necessary. Now I'm gonna hand over the presentation to Ralph.
Thanks again, Andras. Nice to see that link in operation from start all the way through to finish. I'm just going to backtrack a little bit before I go through the functionality within Checkbot, our hub. And this is predominantly about why we actually do something that I call connected connection design. And that's because information is important, and duplicating information is dangerous as well as wasteful. I've lost count how many times I've heard of the wrong values being used, predominantly because the information has had to be retyped into a completely different solution. And this day and age, we shouldn't be doing that. We should be concentrating on using the right information in the right place at the right time. Collaboration is the key, not only between solutions like MasterSeries and IDEA StatiCa, but also collaboration between different solutions as well. And you might be asking yourselves as to why do I need IDEA StatiCa? Well, the simple answer that Andras has already highlighted as well is that this follows the classic 80-20 rule, in that you can do 80% of your connections in MasterSeries in 20% of the time, and that is wonderful. But the remaining 20% of those connections, which unfortunately you can't do, takes a hell of a lot longer to accomplish. And that's where solutions like IDEA StatiCa come to the front to help you solve that conundrum with regards to the rest of the time that it takes to do connection design. And a little bit about the theory behind IDEA StatiCa. It still complies with Eurocode because it uses the CBFEM method, which is a synergy between the component-based method and a finite element analysis model. So that if we look at a simple bolted joint, for instance, that is comprised of the various components of the model, which are the members, the plates, the welds, and the bolts. And these are modeled as either shell elements or specifically nonlinear springs. That is pulled together to create the CBFEM model, which allows us to visualize a connection not only sort of like geometrically, but also dive into what's happening with it from a material perspective. And we can then check the individual material and components against their code design standards. It's not just a black box. The methodologies have been verified by top universities around the world, not only in Europe, but also further afield as well in America. And we'll be conducting some in the UK shortly, not just for stress and strain, but we also do have built into the software advanced analysis methods for buckling, stiffness, and capacity design as well. What stiffness allows you to do is to you reuse some of those stiffness, reuse the actual stiffness of the connection itself back into your software. And I guess the next thing to go on to is what it looks like in reality. So this is the Checkbot model that Andrag left you all with. And in this, we can see the design groups that have been automatically created by the algorithm built into Checkbot. At its first point, you will see a summary of the connections that are required to be designed, checked, those that have been passed or not passed. Part of the transfer process was to send over not only the structure comprised of the members and the connections, but also their loads. And we can visualize their loads within Checkbot itself, which also aids as a visual aid of confirming the actual process of integration between the members, between the software solutions. And this is visualized for any of the load cases that have been transferred over from MasterSeries through into Checkbot. Once we have those loads and we have our member groups, we can open the associated connection. Bearing in mind that the member or the project that has been transferred has been what you might call either a centerline member or a centroid member. Have we? No. Yep. So part of that process was to modify the offsets for the bracing members so that they take into account the as constructed positions of each member. And as you can see, part of the process of transferring these allows us to look at the load effects or the actual combinations, and we can evaluate the critical load effects. So yes, you're going to end up with a lot of load case combinations when you do your global analysis, but we have algorithms as well as MasterSeries to further refine those load effects into a smaller subset of critical load effects, which is exactly what you need. When we create a connection in IDEA StatiCa, we are using operations. These operations are very, very similar to those that you would find in fabrication. So I want to create a plate. What sort of plate do you want? Where do you want it? And how do you want it to be sized and located? So here, for instance, we're just adding a very simple stiffening plate. We are choosing the material grade and the thickness of the plate, and then we can go on and choose the relative sizes based upon its setting out point. The setting out point can be the node of the connection, or it can be actually related to the member, which forms part of that connection as well. We can control whether or not it has welds, or we can individually weld that after the fact. Part of the workspace involves all the visual feedback that you require to know that the input that you are putting into the panel to the right is being interpreted correctly by the actual software, and also you're making sure you're getting the right dimensions in the right place. So that simple operation is supplemented by, let's say, for instance, a cut of a member. And for this, we're going to cut one member against the plate. If we don't know the name of the plate, we can select it and it fills it in into the correct panel. We don't have to do this manual operations every single time. If there are like operations, then we can copy one and just change the parameters of the input. Now, I'm not going to take you through every single operation within this connection, because that would take us well over the hour mark if we're going to get some questions into this. So looking at the bolts next, which are one of the most complicated things to set out in any solution, we use a very simple syntax to define where the bolts are positioned around the center of the plate or connection, and we can just define the number of rows where they are and the number of columns, and again where they are. And as you can see, we can position those to suit. Relatively easy syntax to get to grips with, and again, the visual feedback that you get within the workspace helps no end to position these bolts correctly. So pushing those bolts further afield and decreasing the edge distances allows us to, or increasing the edge distances, the offsets from the center line, I should say, allows us to get those bolts in the right place. Furthermore, we have access to a drawing of the plate, which actually confirms with real dimensions what those bolt positions now are. And again, making sure that we've got them in the right place for the actual design itself. So once we populate the connection with all of the operations required for the connection to perform as required, we can see that that is quite a complex connection in the end, but it's still not going to take you very long to create something like this once you get an understanding of how IDEA StatiCa works. So we have two end plates, two supplementary plates that are manually welded to the members, the bottom chords, and the braces that we've already offset by 30mm will connect to that gusset plate with a inline bolted connection, but the core, the braces themselves will need to be cut against several members, against two members each, in fact, and that is exactly what we've done there. So when we analyze this, we are going through each individual load case and looking at the design as a simple pass or fail to begin with against each individual load effect or load combination. The first thing that we see is what we call a traffic light, and what that is showing us is whether or not it passes. Grey indicates that it's passing really well. Green is good. Amber is on its way to being red, which is bad, which is a fail of a part of the design itself. So helps you not to do too much too soon. Once we're into detailed checks, we can look at stresses, strains, contact stresses, and also the deformed shape, which helps to visualize the effects of the incoming loads. We can also see the bolt forces in this diagram as well, which helps us to understand additional effects that are taking place within the connection, such as prying. We have detailed checks on the plates, bolts, and welds, and what that looks like essentially is a summary of the effects and the code checks. If we highlight a plate within the workspace, we see that plate in detail view below, and again we can look at if we were to look at the bolts, we can see the resultant directions of the bolt forces. Looking at a preview for the bolt calculation itself, we're doing all of the checks required by Eurocode, including the utilizations at the end and combined utilizations. The same applies for the welds. Not only are we looking at the distribution of stress along the weld, but we're also looking at the utilizations again for those individual welds. In the report, not only do we have the standard input, but we also have the ability to take user-generated screenshots. So if you see a particular view that you want that shows the results in slightly better, then we can just do you can just do a simple print screen and incorporate those into the report. The report itself can be printed off directly or saved to a Word document or PDF, all from within the solution itself. The reports are customizable and you can save them for future use. Relying on taking collaboration to the next step, we also have a viewer facility, which allows you to share your chosen connection design as a read-only web-based viewer to others within the design team. So this allows for very simple collaboration workflow between one designer and another. And that is my side of the webinar done, and I will make Andras the presenter again. Thank you very much.
Okay, thank you, Ralph, for that insightful presentation. We will now move on to the Q&A section. Okay, let's look at the questions. So someone asked, what is the upper limit for number of load cases to import to Checkbot? Technically, there is no limit for load cases. Ralph, do you know any limits for the number of load cases?
I think probably the only limit is the limit of the engineer's patience. As you pointed out before,
Right.
the more load cases you have, the longer
Yes.
things take, not only in export, but also in design. And that applies to both MasterSeries and IDEA. So,
yes,
I think it's incumbent on the engineer to really think about the load case combinations that are being produced, and that that they recognize that more is not better.
Yes, that's correct. The export time really depends on the size of the model and the number of the combinations you selected, and it also depends on how many internal points you need for the export. So it's really model dependent. Okay, we also received a couple of questions regarding connection stiffness. So Ralph mentioned that IDEA StatiCa calculate the actual connection stiffness. Unfortunately, the link is a one-directional link, so at the moment we can't send back the stiffness from IDEA StatiCa to MasterSeries. So at the moment we can't use the calculated connection stiffness. Okay, just looking at the questions. Does Checkbot automatically recognize the connection design groups? No, the design groups can be assigned for the MasterSeries connections within the MasterSeries. At the moment, there is no functionality to assign them as a group connection and using them for the link. Okay, there's a question for you, Ralph. Someone asked if they can use your tool to design stainless steel connection.
It's for normal grades of steel. There are ways that you can use a different material, but we do not have the code checks built in for stainless steel. You might be able to get a modicum of an approximate result, but it's not fully supported. I might have dropped out there.
Okay, yes, this is the same with the MasterSeries. MasterSeries design to the normal steel grades, so the stainless steel part of the Eurocode are not implemented in the MasterSeries at the moment. Once connection is designed, can it be recalculated if there are any changes in the model? So yes, we can synchronize the two models. So the link between MasterSeries and IDEA StatiCa remains live. So if you need to update your result, then you can do this. Ralph, I believe you have also the option to recalculate the connections for the new loads.
Yeah, I mean, Andreas is right. Once the connection between MasterSeries and Checkbot has been re-established, we can sync the updates with regards to members and their connections, but also if there's been any load effect change. So we can actually recalculate based on new analysis results as well.
Okay, there's another question regarding the updating model. So if the MasterSeries export is provided, will be the connections be updated to reflect the new structure? So
what will happen is the old results will become invalid if the members have changed or in direction or orientation. You might have to do some tidying up of an existing connection design. Say, for instance, maybe the cuts aren't working as expected, and then you will have to recalculate. Now, the groups that we create, which sort of mimic your design groups as well, allows us to model one reference connection within the group and use all of the subsequent connections, the values within the load effects for the design check. So we don't have to amend 20 connections. We can still just amend the one connection and do the rolling check thereafter. So, and also if you set your connection up properly to begin with, you can actually take into account the possibility of changes going forward.
Okay, yes, there is another question on class 4 cross sections. So can you handle class 4 cross sections as well?
Class 4, yes, we can handle. The important thing to recognize with class 4 is their susceptibility to local buckling, which is why I mentioned buckling at the beginning of my part within this webinar. It's an important feature of those thin-walled sections.
Is there any restriction on geometry in IDEA?
Okay, the only restriction is the engineer's imagination. Basically, I have a saying that if you can model it, we can analyze it. So yeah, it's all down to the engineer and the input not only is it with the topology of the joint, the angles and the positions of the members, but it's also the types of members, the sections for the members that we can use as well and adapt. So compound, composite sections can be used. Any shape of section can be used, particularly suitable for class 4 or cold formed. So it's all down to the engineer's imagination and requirements at the end of the day.
Okay, probably you already have some informations and feedbacks on your design workflow. So do you have any idea how much time you can save using this combined approach?
Well, yeah, we've talked about this and we've had surveys as well, internally and externally commissioned, which is why I quote the 80-20 rule. So it doesn't matter the size of your project. You know, it might be 70-30 or 90-10 for some projects, but on average, that 80-20 rule really does bear out. And you know, if you've got a small project and it takes you, let's say, 4 days to do your connections, and then it's going to take you another 4 days, and then we're going to hopefully shrink that down to 2 days. Or less even. I haven't had enough coffees this morning, so I'm not sure if my maths is working properly. But the time savings are significant at the end of the day. But combined approach between MasterSeries and IDEA StatiCa that's the key to it.
Okay, great. So, ladies and gentlemen, thank you for participating in today's joint webinar. You can reach us through our website or social media for more information. We look forward to hearing your feedback and continuing to support your projects with our software solutions. So thanks again for joining us and have a great day.
Thank you very much.